I wanted to post a quick update on my first impressions of this vise. When I checked it originally, my old vise, I ran the same test and I got almost no movement, which led me to believe that my table and my column on my mill were perpendicular. The follow-up is really showing that wasn't true. So it's kind of astounding that they were perfectly out of sync together. But what I did is I went through and re-trammed or re-shimmed my back column, and I just wanted to go ahead and show the results here, which are pretty good. So I'll run it down. And I put a ruler there, which is going to be hard to see, but just to give you an idea of how far I'm actually traveling. So it's much better. There's still some out of squareness happening, but overall I think I think the tramming has worked out. I'm still not perfectly, the column's still not perfectly perpendicular, but it's pretty darn close. And I'm a lot happier with the mill right now, or the vise right now, just based on that result. Now, one of the things I do want to point out is that I've got my X and my Y gibs tightened down. Obviously, I can't run the spindle up and down without keeping the Z gib loose, and when it comes down, it's definitely wiggling. When it goes up, it seems quite a bit smoother. So I'll just run it back up just to show you. So it looks like about roughly 4/100ths of a millimeter over about 350 millimeters. I think that's pretty good. And again, most of that is probably my column and my tram setup for my shimming for my column, which turns out it wasn't really good in the first place. The other thing I just want to do real quick while I've got everything set up, I'm going to take the pressure off. And that's quite a bit of movement. That's a bit of a surprise. And I just want to, and I'm just going to have it touch this back jaw. Now, when I first did this test, and the way that the vise was shipped to me, these jaws on the front and the back both can float, but what you can also do is you can screw the vise shut and tighten. There's 4 screws, 2 for each jaw. You can tighten these so they're fully seated down to this registration point down here. Now, when I first tested this, they were tightened down like crazy, and they were seated in this down position. The way that this works when they're not tightened down into the down position is when you clamp the jaws, it'll actually create a downward force. So if you have a parallel, or you have like this 2, 4, 6 block, it'll actually pull this down into this precision ground surface here, which should give you better registration. It should prevent you from having to tap things down with a hammer to make sure you're seated, tightly down onto your parallels or whatever you're working on. But what I want to do here with this next test, I'm just going to push it back. Now, this introduces maybe a little bit of error if I was trying to tram my X in or my vise in. because this floats, and if this is cocked or the springs don't have it pushed up in exactly the right position, you're going to get a false reading. So if you're going to tram this, you really want to have something like a parallel clamped in there and then tram to the parallel, not the jaw face. So anyway, let me go ahead and I just want to get a quick reading. So I just want to get a quick reading of it just sitting, just touching this back plate. So there's really nothing holding it in place other than its own weight. So I'll go ahead and run it down. We'll see what this looks like. I crashed. Okay, so that's a little less than 77. I would say there's about 0.04 of a millimeter over whatever this distance is. 200 millimeters, 250 millimeters. So that's about how far out my column is, or that's how far out the vise is registered on the table, like if there was a chip under there or something. I wasn't able to get the column trammed in any closer than this. So this is better than it's twice as accurate as it was when I first had it set up. So I'm happy with that, and the surface finish is looking pretty good. So that's my follow-up on the vise here. I've been using it. I really like the feature, how these pull downs work. I haven't had any issues with it other than there was at one point where I think I over tightened this and I had a hard time loosening it, but that's not really a big deal. One of the things that I've noticed is the chips definitely accumulate in here, and I should probably make a cover for it just to sit right here so that the chips don't accumulate in this thread. And the other thing, and maybe the downside of this system where these jaws pull down, if you get any chips behind the surface, everything's going to get thrown out. And I'm not sure how likely that is. They definitely make quite a set of noises when you crank them down. I'll just go ahead and crank it down real quick so you can see that clamping action. That's not the noise I was talking about. Well, that was actually surprisingly quiet, but sometimes they grab and they make a little bit of a popping noise. So I think I'm just going to have to keep a really close eye on if there's any chips here or if there's any chips down here on this surface, because while this is pretty hard material, I do think that might cause some wear problems. It might cause some scratching, but it definitely would cause these things to get out of alignment. And it's less important. It's really less important on this this rear jaw. It's super important on this jaw here, because this is what's going to give you all the registration for your tramming and the squareness of the vise. So yeah, I made a mistake, and I just wanted to correct it so that people get the right impression of this this vise design. I also did want to call out that there's a YouTuber, and I don't really know how to pronounce his name. I think it's Kalem. I'll leave a link down below. He actually made one of these, which is an impressive feat, and I'll try to link that in the description. So if you have any questions, let me know, and thanks for watching.